In this lecture, we are going to find particular integral of f of d into y is equal to q of x, where q of x is equal to sin ax or cos ax. The particular integral is equal to 1 by f of d into sin ax or cos ax. The working rule. First step is to find the complementary function which we discussed in the previous lectures. And particular integral is equal to 1 by f of d square into sin ax or cos ax. The denominator of the function should be written in the form of d square. Then the first step is to substitute d square by minus a square. Then the denominator of f of d reduces to a linear form of the form LD plus or minus m. Since we have substituted our d square, we are left only with our d term and a constant term, which is nothing but LD plus or minus m. Now, multiply numerator and denominator with the conjugate of the obtained linear form. For this obtained linear form, we have to find the conjugate. Conjugate means if LD plus m is the linear form, then LD minus m will be the conjugate. LD minus m will be the conjugate, and if LD minus m is the linear factor, then LD plus m will be the conjugate. So this is the conjugate concept. Now multiply the conjugate term in the numerator as well as in the denominator. Then denominator reduces to L square d square minus m square, since a plus b into a minus b is equal to a square minus b square. So again, substituting d square by minus a square, now the denominator reduces to a constant, whereas the numerator will be in the form of LD plus or minus m sin ax or cos ax. We know that sin ax, d of sin ax is nothing but derivative of sin ax with respect to x. Since d is nothing but our differential operator, which is nothing but d by dx. Now this is equal to cos ax into a. Since constant associated with a is with x is a, so in differentiation the constant will get multiplied. So this is equal to a cos ax. Similarly, d cos ax is nothing but minus sin ax into a, which is equal to minus a sin ax. Now let us solve the first problem. D squared minus 4d plus 3 into y is equal to cos 2x. Now given differential equation is in the form of d squared minus 4d plus 3 into y is equal to cos 2x, which is in the form of f of d into y is equal to q of x. The first step is to construct the complementary function. For constructing the complementary function, the auxiliary equation should be written, which is f of m is equal to 0. Implies m squared minus 4m plus 3 is equal to 0. If we factorize this, it will be m minus 3 into m minus 1 is equal to 0. Implies the roots are 3, 1. So clearly the roots are real and distinct. Hence, by the previous method as we have discussed, complementary function is equal to c1 e power 3x plus c2 e power x. So now finding the particular integral is equal to 1 by f of d, which is nothing but 1 by d square minus 4d plus 3 into cos 2x. First of all, we have to observe the coefficient of x in the trigonometric function cos or sin. So since a is equal to 2, you have to substitute your d square by minus a square, which is nothing but minus 4. So d should not be touched, d should be kept as it is. Then 1 by minus 4 into minus 4d plus 3 into cos 2x, which is equal to 1 by minus 4d minus 1 into cos 2x. Now we have to find the conjugate for this minus 4d minus 1. The conjugate for minus 4d minus 1 is minus 4d plus 1. Now multiply with the conjugate in the numerator as well as in the denominator. Then it will be minus 4d plus 1 by minus 4d plus 1 into minus 4d minus 1 into cos 2x. Since numerator will be minus 4d plus 1 and the denominator will take the form 16d square minus 1, since it is a plus b into a minus b into cos 2x. Now it is in the form of minus 4d plus 1 by 16d square minus 1. Again, you have to substitute your d square by minus j square, which is equal to minus 4. Then minus 4d plus 1 by 16 into minus 4 minus 1 into cos 2x. Now we can observe that the denominator is converted to a constant, which is nothing but minus 1 by 65 into minus 4d plus 1 into cos 2x. Now this cos 2x should be multiplied inside. Means is equal to minus 4d cos 2x plus cos 2x. D cos 2x is nothing but derivative of cos 2x with respect to x. So minus 4, minus 1 by 65 into minus 4 into, since the constant is 2 into cos becomes minus sin 2x plus cos 2x. So it is clearly minus 1 by 65 into plus 8 sin 2x plus cos 2x. So therefore the particular integral is equal to minus 1 by 65 into 8 sin 2x plus cos 2x. Now by 1 and 2, which is nothing but complementary function and particular integral, the solution is equal to complementary function plus particular integral, which is equal to c1 e power 3x plus c2 e power x minus 1 by 65 into 8 sin 2x plus cos 2x. So for the next problems, the following trigonometric problems are important. 2 cos square x is equal to cos 2x plus 1 and 2 sin square x is equal to 1 minus cos 2x and 2 sin a cos b is equal to sin a plus b plus sin a minus b. 2 cos b is equal to cos a plus b plus cos a minus b. 2 sin a sin b is equal to cos a minus b minus cos a plus b. This is a very important formula because you will get confused here. First cos a minus b should come in the front, then minus cos a plus b. Now cos of minus theta is equal to cos theta. Negative angle will not come in the cos trigonometric function, whereas sin minus theta is equal to minus sin theta. Now the next problem, solve d square minus 4d plus 3 into y is equal to sin 3x cos 2x. So the given differential equation is in the form of f of d into y is equal to q of x. The solution is y is equal to complementary function plus particular integral. So here sin 2x, sin 3x cos 2x should be written as addition of sin and cos trigonometric functions. So we are using this formula, sin a cos b is equal to sin a plus b plus sin a minus b. So it is sin 3x plus 2x plus sin 3x minus 2x. So which implies 1 by 2 into sin 5x plus sin x. So to find the complementary function, the auxiliary equation is written as f of m is equal to 0, m squared minus 4m plus 3 is equal to 0. After factorization, it will be m minus 3 into m minus 1 is equal to 0. So m is equal to 3 comma 1. The roots are real and distinct. Therefore, complementary function is equal to c1 e power 3x plus c2 e power x. Now, to find the particular integral, since it is having two terms, the particular integral is split into two parts. Particular integral 1 plus particular integral 2. Means the first particular integral 1 is constructed with respect to sin 5x and particular integral 2 will be constructed with respect to sin x. Now, first of all, find out particular integral 1, which is equal to 1 by d square minus 4d plus 3 into sin 5x. As we have noticed, the coefficient of x is 5 here. So we have to replace our d square by minus j square, which is equal to minus 25. So 1 by minus 25 minus 4d plus 3 into sin 5x, which is equal to 1 by minus 22 minus 4d into sin 5. Now the conjugate of minus 4d minus 22 is minus 4d plus 22. So multiply numerator and as well as denominator by minus 4d plus 22. So it is minus 4d plus 22 by minus 4d plus 22 into minus 4d minus 22 into sin 5x, which is equal to minus 4d plus 22 by 16d square minus 484 into sin 5x. Now again substitute your d square by minus j square, which is equal to minus 25. Then minus 4d plus 22 by 16 into minus 24 minus 484 into sin 5x. this is equal to minus 2 into 2d minus 11 by minus 400 into sine 5x, which is equal to 1 by 200 into 2d minus 11 into sine 5x, which is equal to 1 by 200 into, now multiply your sine 5x inside, 2d sine x minus 11 sine 5x. So differentiating with respect to x, sine 5x, 5 is a constant associated with x, so it should be multiplied. So 2 into 5 into cos 5x minus 11 sine 5x. So particular integral 1 is equal to 1 by 200 into 10 cos 5x minus 11 sine 5x. Now to find the particular integral 2 is respect to sine x. So 1 by d square minus 4d plus 3 into sine x. Since a value is equal to 1, then put d square is equal to minus j square, which is equal to minus 1. So this is equal to 1 by minus 1 minus 4d plus 3 into sine x, which is equal to 1 by 2 minus 4d into sine x. Now the conjugate of this will be 2 plus 4d. Now multiply numerator and denominator with 2 plus 4d. 2 plus 4d by 2 plus 4d into 2 minus 4d into sine x. So 2 plus 4d by 4 minus 16d square into sine x. Again, if you substitute d square is equal to minus a square, which is equal to minus 1, then 2d plus 4d by 2 plus 4d by 4 minus 16 into minus 1 into sine x. So this will become 20. So denominator becomes constant here. Now we can multiply our sine x into the numerator, which is equal to 1 by 20 into 2 sine x plus 4d sine x. D sine x is nothing but differentiating sine x with respect to x, it will be cos x. So 1 by 20 into 2 sine x plus 4 cos x. This is particular integral 2. Now, particular integral is equal to 1 by 2 into 1 by 200 plus 1 by 200 into 10 cos 5x minus 11 sin 5x plus 1 by 10 into sin x plus 2 cos x. Now, the particular solution is obtained. Now, substituting these two in the given solution, then it is complementary function plus particular integral. So, complementary function is c1 e power 3x plus c2 e power x plus 1 by 2 into 1 by 200 into 10 cos 5x minus 11 sin 5x plus 10 in 1 by 10 into sin x plus 2 cos x. Next problem, solve d cube plus 4d into y is equal to 5 plus sin 2x. The given differential equation is d cube plus 4d into y is equal to 5 plus sin 2x. It is in the form of f of d into y is equal to q of x. Now the solution is y is equal to complementary function plus particular integral. To find complementary function, the auxiliary equation is written as f of m is equal to 0. So m cube plus 4m is equal to 0. If you take m outside, it is m into m square plus 4 is equal to 0. Then m is equal to 0, comma, m square plus 4 is equal to 0. M square plus 4 is equal to 0 means m is equal to plus or minus 2. Means the roots are combination of both real and imaginary. So therefore, the complementary function is c1 e power 0x for the real root plus e power 0x, which is nothing but 0 plus or minus 2i, e power 0x into c2 cos 2x plus c3 sin 2x. So since e power 0 is equal to 1, so complementary function is equal to c1 plus c2 cos 2x plus c3 sin 2x. Now to find the particular integral is split into two parts because it is having two parts, 5 plus sin 2x. So let us find the particular integral for 5 first, then sin 2x. Then particular integral 1 is equal to 1 by d cube plus 4d into 5. Since we have discussed in the earlier lectures, 5 should be considered as 5 into e power 0x. So it is equal to 5 into 1 by d cube plus 4d into e power 0x. So since a is equal to 0, you have to put d is equal to 0. Then f of 0 is equal to 0 cube plus 4 into 0. Obviously, it is equal to 0. So again, you have to find the derivative, which is nothing but f dash of d, which is equal to 3d square plus 4. So again, if you substitute in the place of d by 0, it will be 3 into 0 square plus 4, which is not equal to 0. So particular integral 1 is equal to x by f dash of 0 into 5 into e power 0x, which is equal to x by 4 into 5, which is equal to 5x by 4. So this is nothing but our particular integral 1. Now to find the particular integral 2, which is the trigonometric function sine 2x. Now here d cube should be written as in the terms of d square only we can substitute by minus a square. So d cube is written as d into d square plus 4d into sine 2x. Since coefficient of x is 2 here, means a is equal to 2, you have to substitute d square is equal to minus a square, which is equal to minus 4. Here we have to observe carefully that minus 4d plus 4d, always denominator is equal to 0. So always denominator should not be equal to 0. In such cases, we have to multiply the numerator by x and find the derivative for the denominator, which is equal to 3d square plus 4 into sine 2x. Now you substitute your a. Since a is equal to 2, you substitute d square by minus 4. Now if you substitute d square is equal to minus 4, then particular integral 2 will be equal to x by 3 into minus 4 plus 4 into sine 2x, which is equal to x by minus 12 plus 4 into sine 2x, which is minus x by 8 into sine 2x. Since the numerator is not having any term in d, there is no need to multiply sine 2x inside. So therefore, particular integral 2 is equal to minus x by 8 into sine 2x. Now the particular integral will be obtained by adding both particular integral 1 and particular integral 2, which is nothing but particular integral is equal to 5x by 4 minus x by 8 into sine 2x. Now the solution is obtained by substituting 1 and 4 in the equation A, which is equal to complementary function plus particular integral.